Hello, everybody. Good day. Welcome to our channel. Today, I'm going to talk about the Gauss-Jordan method of solving systems of linear equations. Okay, so I'll share my screen. Okay, so today I want to talk about the Gauss-Jordan's method of solving systems of linear equations, and then precisely on the elementary row operations. Okay, so we know that um, with systems of linear equations, we can solve using a lot of methods, but practically in the tertiary institutions, when we are studying or we are looking for methods to solve systems of linear equations, we use the Gauss-Jordan's method. So this Gauss-Jordan's method employs matrices, that's the concept of matrices, to solve systems of linear equations and then derive the values for the unknowns. So when we talk about unknowns, those are the variables in equations that we solve for to get their values. So for example, I write something like 2x plus y is equal to 3. So from this example, x and then y are the unknown variables that you are supposed to find. And when we talk about systems of linear equations, we mean a set of equations or let's say a set of equations that when you find the value for the unknowns, to be able to satisfy each equation. So if I add, say, 5x plus 2y is equal to 2, then this become a system or a set of linear equations. So in this video, we are come to learn about how to use the Gauss-Jordan's method to solve these systems of linear equations and derive the values for the unknowns, that's x and y. So under this method, we have the elementary row operations. So it's just a method whereby we work on the various rows in a matrix in order to solve for the unknowns. In my previous lecture or video, we talked about multiplication of matrices. Then we saw how matrices are defined, the various dimensions. And then we realized that matrix has rows and columns. So under this method, we just work on the rows in order to come out with a solution. So first of all, you need to know what an identity element is. So when we talk about an identity element or an identity matrix, inputs in an identity matrix is just an array of numbers which includes zeros and then ones. And then identity matrices are square matrices. When you talk about square matrix, it means that a matrix with what equal number of rows and columns. We know that with the shape square, all the sides are equal, right? So with identity matrix, it has equal number of rows and equal number of rows and then columns. So for example, let's say we have I. So we use I to represent identity matrix. Let's say we have 1, 0. So this is an identity matrix because it includes ones and zeros. And then we can see that it has the same number of rows, that's 1 to 2 rows and then one to two columns. So this makes it an identity matrix. So employing the Gauss-Jordan method is telling us that we have to first, or when we change the equation to matrix, we need to turn that matrix into an identity element. So basically changing the matrix into an identity element and performing other operations to get the answer. So for example, let's say using this equation, if you want to use the Gauss-Jordan method to solve this equation, the first thing that you have to do is to first translate the equation into a matrix form. So if you are writing this into a matrix form, you have to first check whether the unknowns are arranged in the same order. What I mean is that, you see, in this equation, we have 2x plus y is equal to 3, 5x plus 2y is equal to 2. So the x here and then the x down here, they are in the same order, or they are in the same column. The y here and then the 2 here, they are also in the same column. So suppose we have, or they give you a question, then they've written 2x plus y is equal to 3, and y plus 2x is equal to 4. Then you are asked to use the Gauss-Jordan's method to solve this systems, or this set of linear equations. First, we see that the x and the x, they are not in the same position, or they are not arranged in the same column. When you look at this place, x is here, y is here, y is here, x is here. So if you are supposed to solve this and you don't change it to make it look like this, then whatever you do, your answer will be wrong. So you have to first check, are my x unknowns, are they in the same column? And is the y also in the same column? If not, you have to first interchange them to make them look like this. 2x plus y is equal to 3. 2x plus y is equal to 4. So when you do this, then you can go ahead and solve with the Gauss-Jordan method. Else, if you just go on straightforward from this point, you're going to get everything wrong and get stuck on the way. So that's the first thing you should take note. I have to make sure that the unknowns are in the same column, like this, not like this. Please, I hope you understand that. All right, so this is the correct way and this is wrong. Please, do you get me? Okay, so then we'll move on to the next step. So after arranging the equation to this form, then you have to translate the equation to a matrix. Then this is the simplest part of the method, because all you have to do is just bring your square bracket, pick the 2 here, write the next coefficient here, which is 1, write this 2 here, just bring it down here, then the 1, you also bring it here. That's grouping the coefficients. It's very simple. Then the next thing is you group the unknowns. This is just x and then y, because x comes before y. Let's say if the equation was 2y plus 2x is equal to 1. And then we have 3y plus x is equal to say 2. Then in this point, at this point, when you are translating it to a matrix, then when you write it this way, 2, then the 2, 3, then the 1. When you are writing the unknowns or you are grouping the unknowns, you have to bring the y first before the x. Just because in our alphabet x comes before y doesn't mean when you are grouping them in matrices, the x must come before the y. Based on the information given, that is what will give you the clue on how to arrange your unknowns. So at this point, the y came first before the x. So it means that when you're arranging the unknowns, the y must come first before the x. If you want to write it this way, then you have to rewrite your equation, and then the x must come first. Then you get 2x plus 2y is equal to 1. Then the x will come in x plus 3y is equal to 2. So when you change it this way, then it means that the coefficient grouping will also change. That means it become 2, 2, and then 1, 3. That's when you can bring the x and the y. I'm starting with this because sometimes the question might not be straightforward. But if you just put your mind to just one method, that when you just see the question, you just start grouping the coefficients, you're going to get it wrong. You have to first check whether the unknowns they are in the same column or not, and then which unknown comes first before you start the grouping. Okay, so let me use another screen. So I hope we got that. So now let's write another equation. Let's say 2x plus 2 plus 2y is equal to 1. 3x plus 4y is equal to 6. Let's say we have something like this. So what I've said so far, see that the x unknowns are in the same column, the y is also in the same column. Then it means that we are good to go. So you first write it in the matrix form. That's group the coefficients at one side. That's the 2. When you talk about coefficient, it means the preceding values of an unknown. That's this, the 2, the 2, the 3, the 4. So we have 2, 2, 3, 4. Then from the equation, we know that x comes before y. So it means that we have our x, we have our y is equal to, and we will group our results. We also group them. So with the Gauss-Jordan method, the first thing you do after checking whether the unknowns are in the same column is to group them to the same field or category. So this is the coefficient side, this is the unknown side. Then we have the result, or let's say the resource side, which is 1 and then 6. Hope you understand it. So after grouping it, then if your lecturer is marking, give you 1 point for it. So this is basically the first step. I hope this point is easy to understand. All right, so let's say we have another equation like 2y is equal to 1. Then we have 3x plus y is equal to 2. So with this set of linear equations, we see that in the first equation we have only y. So just because y is just the only variable, that doesn't mean go ahead and then solve for y, because the question said use Gauss-Jordan's method. So because there's only y here, but in the whole set of equations, we have two unknowns or two variables, which is x and y, then it should tell you that this point or this side of this equation x was 0x. But we know that 0 times anything or any number is 0. So if let's say x is 5, 0 times 5 will be 0. That's why they got rid of the 0x. But you have to know that since a set of linear equations have two unknowns, that's the x and then the y, then it means that in the first equation there is what a hidden x, which is 0x. So when you are starting with this, it means this x has a coefficient of 0. So it has to be here, that's 0. This one has the coefficient 2. So it also has to be here 2. Then you bring the 3, then the 1. I use this example because I often see this in questions. So if you are not diligent enough, you might not know that this x has a coefficient of 0, but they omitted it because every number divided by any number times 0 is 0. But you have to know that since we are dealing with two unknowns, and if the x is not there, it means its coefficient is 0. So when you are grouping the coefficient, the 0 must replace this point. Then you group the unknowns to which is x and y, which is y. Then you also group the results, that's the result, which is 1, 1, and then 2. Is I hope you understand this point. I'm taking my time because if we get this whole point wrong, means everything I'm going to do next is going to be wrong. All right, so if this side is understood, then we'll move on to now how to calculate the jaws, how to translate the matrix to an identity element using the Gauss-Jordan method. So let me use a new screen. So here, before you can use the Gauss-Jordan method after translating the equation to a matrix. So let me rewrite the matrix here. So let's say we have 2 and then 1. We have 3 and then 1. Then we have x and then y is equal to 1 and then 2. So let's say this, after translating our equation to a matrix, this is what we get. So let's label this as matrix A. Then the unknowns, we'll label it as matrix X. Then with the resource or the result, we'll label that as matrix B. So we are saying that A or matrix A multiplied by matrix B should give us matrix what? Matrix B. So A multiplied by matrix X rather should give us matrix B. So now, using the Gauss-Jordan method, we are asked to change this matrix into an identity form before, or so that at the end we'll be able to get an answer for the unknowns. But first, before you can change any matrix to an identity form, we have to check whether the matrix is also a square matrix. That is, the matrix has the same number of rows and then columns. Because if the matrix doesn't have the same number of rows and columns, it won't have an identity element. So you can only change a matrix to an identity element, an identity matrix, only if it has the same number of rows and columns. So here we can see that the number of columns here are 2, the number of rows here are 2. So it means that we can have an identity element for this, which would look like this: 1, 0, 0, 1. So sometimes one may ask that how can I determine the identity matrix of a non-identity matrix? So the basic thing that I can say is that with identity matrix, if it is a 2 by 2 matrix, it will have 2 ones. If it is a 3 by 3 matrix, it will have 3 ones. If it is a 4 by 4 matrix, it will have 4 ones. And the ones are grouped in such a way that they are in diagonal form, so like this form. So as you move down the the number of columns or the number of rows, then the ones also increase. So this is a 2 by 2 matrix. So say we are writing an identity element for a 3 by 3 matrix, then it will look like this. We are saying that if it's a 3 by 3 matrix, it will have 3 ones. So, and 3 by 3 matrix means 3 rows and then 3 columns. So if it will have 3 ones and they'll be in a diagonal form, means the first one will start here, the second one will start here, and then the third one will end here. So the rest of the spots to make it a 3 by 3 matrix will be zeros. So here you write 0, 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 and then for here to write 0. Then you get your 3 by 3 identity matrix. If it is a 4 by 4 identity matrix, then it means you have 4 ones in it. So you start here, 1, then the second one, then the third one, then the fourth one. So the rest will have what? Only zeros. So we have 0, then we have 0, 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 and we have 0. So this is how a 4 by 4 identity matrix would look like. So identity matrix is not difficult to write. All you have to know that based on the dimensions of the matrix, if it's a 3 by 3, it's meant to have 3 ones. You write them, you start from the top, the next one will move, it will move, and then it will move. Then the other parts of the matrix will contain only zeros. Then that's it. I hope you understand the identity matrix. So we are told to change this matrix A into an identity matrix. Then we'll work on the results to get back our knowns. So somehow, as well should we work on the results? So one property of matrix is that whatever happens to the left side also happens to the right side. That is left and right distributive property. So whatever happens to the left side of the matrix or matrix in an equation also happens to the right side of the matrix. But in basic algebra, let's look at this. So let's say we have 2x plus 3y is equal to 1. So we know that we are asked to find x and y, and then we are given 1 as a constraint. So let's say that 1 is our money, right? So it means that whatever we will do or to get x and y will be dependent on the money we have. So if let's say I have 5 cedis and I want to enjoy orange and then banana, the amount that I'll buy will be dependent on the money that I'm having, right? So that's why to find the unknowns will be dependent also on the what? On the result or the resource here. That's why we include this in the Gauss-Jordan method when you are finding for the unknowns. Because whatever happens to this, to the unknowns, is influenced by our resources, which is this aspect. So in the Gauss-Jordan method, So in the Gauss-Jordan method, we are asked to what? To convert the main matrix, which is matrix A, and then the resource, which is matrix B. But in this case, we'll be converting the matrix A to an identity element. And since whatever happens to the left side will affect what happens to the right side, or an effect on the resource is going to have an effect on the unknowns or what we buy, then we have to augment or combine the two matrices so that when we are doing the operations on them, we might not forget that we have a resource part of it. So let me rewrite the matrix again. So we have 2, 3, 3, 1. We have X and then Y. Then we have 1 and then 2. So what this is telling us that after you have translated the systems of equations into matrix form, the next step is to augment the matrix A and then the matrix B, because the movement of this, that's B, will affect X and Y, but X and Y will not change. Well, the X and Y will not be used in this aspect. Do you get it? So we just use the coefficient matrix and then the resultant matrix. So that's matrix A and B. So when we say we augment, we write it like this. Then you bring this bar. That would tell anybody or your lecturer or someone marking your script or someone you are helping that we are augmenting this matrix and this matrix so that when you are performing operations, you'll be able to perform them on the result too. So this is what we call augmenting the matrix A and then the matrix B. Hope you understand this part. So after you've augmented them, that is when the real deal what happens. But if you don't go through all what I've said starting this lecture, then you'll not be able to get your real answer when you are performing the actual operations. I hope you understand that point. Okay, so now we are coming to learn how to effect the Jordan's method on this equation in order to get X and Y. So please, this equation is just something I formulated. I'm not sure whether it's correct or not. So let's using it for this lecture's sake. So the first thing we have to know is before you can use the Gauss-Jordan method, we have 3 types. The type 1 is adding rows. You know, I said from the beginning that we are using the elementary row operations that are working on rows. So the first thing or the first operation we use is adding of rows. That's you can add a row to another row in order to effect a change. So our main focus or what in using this method is changing this matrix into its identity form, which is 1, 0, 0, and then 1. So whatever operations that we are supposed to use should in turn give us a result for this matrix, which is its identity matrix. But whatever we do here will also happen to this place. And the result that we get for this is what represents the values of our unknowns. Yes, I hope you understand. If you have any questions, you can leave it in the comment section too. Okay, so now let's move on. So can add one row to another. So let's say you want to, that means if you want to change row 2, so in this case, this one is called row 1 and this one is called row 2. So let's say you want to add row 1 in the row 2, but you have to ask yourself, which row do I want an effect to take place? So let's say you want row 2 to change. So it means that you start with iteration 1. Iteration 1, or let's say step 1. Step 1. Then you write. So if you want to effect the change on row 2, you write row 2 maps to. Then if you want to add row 1 to row 2, then you say row 2 plus row 1. So our result, or the resulting matches that we'll get, will be the row 1 will be the same, because the effects we are making is on row 2, not on row 1. So the row 1 will remain the same. Then our row 2 will change, because now we are saying we should add row 1 to row 2. So now when you're adding row 1 to row 2, you get 2 plus 3, which will give us a 5. Then 3 plus 1, which will give us a 4. Then 1 plus 2, which will give us a 3. So now this will be our new matrix that we are coming to perform additional operations on. So this is how the new matrix would look like. So that's how we use the addition type of the what elementary row operations. That's adding one row to another one, in order to effect a change on a particular row. So that's how the addition goes. In the same way, you can do subtraction. So let's say we want row 2, we are effecting the change on row 2. But in this case, we are using subtraction. So we can have row 2 minus row 1. And our result will be, so now our effect is going to be on row 2, not on row 1. So you write your row 1 the same way as it is. So let's say this was iteration 1. And now our next step, we want to subtract row 1 from row 2. So now it means this matrix is no more our focus. Our focus will be this. So we'll forget this, because now we've moved to another step. So the next step, we'll be working on this new matches, not on the old one. So the moment you work on the old one, you forget about it. Then you now work on the new one to get another new one. You forget the new, old, and just move on like that. So here we want to subtract row 1 from row 2. So this row 1 and this row 2. So 5 minus 2 will give us back our 3. 4 minus 3 will give us 1. And 3 minus 1 will give us 2. So this is what you will get. Hope this part is okay. So this the addition and then the subtraction parts or type of elementary row operations. So now let's move on to the second type. The second type, which is the multiplication by a scalar. So someone asked that we are saying that elementary row operations, that work combining different rows to get a result. Why is that multiplication? You are saying by a scalar. When you mean a scalar, you just mean we are talking about a number. So a scalar is just a number. It can be 1, -1, 2, but in elementary row operations, 0 can never be a scalar. You can never multiply any row by 0. So the reason why we or with this type of operation, we can't multiply a row by row is, let's say we have this matches like 2, 0, 1, and then 4. We have this, and then we've augmented it with the result. So let's say the result is 3 and then 5. So that's the result. and then we want to multiply or use the multiplication method. So someone will say, why is it that we can't multiply row by row? From the previous video where I taught the multiplication of vertices, realize that before you can multiply two different matrices, there are conditions that you must meet. So let's say you want to multiply this row with this row. So this one is having how many rows? One. It's having how many columns? It's having three columns, right? This one too has one row and three columns. Realize that the column of this, which is 3, and then the row of this, which is 1, they are not the same. So it means that we cannot multiply a row by a row. So that's the reason why we use scalar or a scalar multiple in order to make this method effective. So let's say we want the next iteration is we want to change row 2 by multiplying it by any scalar. So we want to change it by multiplying it by -1. So you say that row 2 is equal to -1 row 2, which means you want to multiply the whole of row 2 by -1. Then it means our result will now look like this. Sorry, I'm coming. Okay, so please let's continue. So we have the 2, 0, and then let's say add 3. So since we are effecting the change on row 2, means the row 1 will remain the same, right? Then the row 2 will change because we are now multiplying it by -1. So now it's become -1, -4, -4, and then -5. So this is how it will look like. So now this will be the result. So you can multiply a row by a scalar, any number except 0. So that's the second operation. You can also divide any row by a scalar by any number. So just as we did the multiplication, multiplying by -1, also choose to divide row 1 by what? 2. So when we divide row 1 by 2, we will get, so now the change is on row 1. So it means row 1 is going to change, but row 2 remain the same. So you first write your row 2 so that you won't get confused. You write your row 2, then you come and now change the row 1. So you are dividing row 1 by 2. So 2 divided by 2 give us 1. 2 divided by 2 give us 0. And then 3 divided by 2 give us 3 over 2. So now this is how our new matrix will look like. Please, I hope you understand this part. So the last part is interchanging rows. So let's say you are given a question, and then in the question, the first coefficient is 0, then maybe you have 1, and we have 1, and then 4. Then we have, let's say, 2, and then 3. Then you are working on this. From our previous talks, we realized that we are making this into 8 identity elements. And what is the identity element for this one? It is 1, 0, 0, 1. I realized that the first point is a 0. You get it? So you can choose that since the second point should start with a 0, then I will interchange row 2 and then row 1 so that the row with the 0 will come down, the row with the 1 will come up. So I have something that looks like this to make my calculation simple. So that one is a discretion. Some people don't usually patronize this method, but sometimes it can be really helpful. So you have to also keep that in mind. So that's the end of the methods that we are using or we use to solve the Gauss-Jordan method. The Gauss-Jordan method, elementary row what operations. So now I'm come to we are going to solve what a question. So I hope that you've understood the basic steps, how I've explained it. If you've been able to understand why we use the Gauss-Jordan method, what you should look out for at the beginning, whether the variables are in the same column before you will separate their coefficients, whether the arrangement of the variables when you are changing them should be in the same order, else your answers are going to be wrong. And also we talked about the methods that we use, the addition or subtraction of rows, the multiplication or division of rows by a scalar, that's a number. The last one, the interchanging of what rows and columns. So now we are come to solve an example so that we'll piece all this together. And I want to show you a simple way, not a simple way, but a way that you can use to solve almost every question regarding Gauss-Jordan method without getting confused. It wasn't easy to come up with that way because I had to practice for a whole 1 week before the Holy Spirit gave me guidance to understand. So I'm going to put a question down, then we'll solve together. So this will be a 3 by 3 matrix. So let's say we have x1 plus 3x2 plus 4x3 is equal to 3. Then we have 2x1 plus 7x2 plus 3x3 is equal to -7. Then we have 2x1 plus 8x2 plus 6x3 is equal to -4. So let's say these are the equations that we'll be working on in this session. So we have been given this question. Using the Gauss-Jordan method, find the unknowns in this question. So the first question you have to ask yourself that, are my equations arranged in such a way that the unknowns are in the same column? So from this side, you can see that the x1 are in the same column, right? The x2, they're also in the same column. Then the x3, they're also in the same column. Then it means that we can move on to the next step. Let's say if x2 was here and x1 was here, means we would have what? Had to interchange them so that the x will be on the same column, the x will be on the same column, and the x will be on the same column. Please, I hope you understand this part. So now we have to, after getting this point, the second step is to translate the equations to matrix form. So how do we do that? You first group the coefficients, then you group the unknowns, and also group the resources. So when you are grouping the coefficients, we get 1 for this part. We get 1 for this part. We get 3 for the next one. We get 4 for the next one. We get 2 for the other one. 7, then 3. Then we get 2. We get 8. Then we get 6. So that's grouping the coefficients. Then the next thing is for us to what? Group the unknowns. So from we can see that x1 comes before x2, x2 comes before x3. So that's the order we write them. Let's say x2 came before x1, before x3, then x2 will come first. But here x1 comes first before x2, before x3. So you have to write it in the same order. So we have x2 and then we have x3 is equal to, then now we group our resources as 3, -7, then -4. So that's the grouping. When you do this, then your lecturer will mark you 2 points, then you are free to go. So after doing this, then now the next step is to augment this matrix and then this matrix, so that we use them to find the unknowns. So the next step is to augment both of them, right? So this is how the augmenting will be: 1, 3, 4. Then we have 2, 7, 3. Then we have 2, 8, or 6. Then you bring this bar sign, and you write your resources, the 3, the -7, and then the -4. The lecture is quite long, but it will be helpful to understand this method. All right, so this is how you augment both words size or both matrices. Before now, you come to the next step. So the next step will be that you have to first know in your head what the identity of this matrix should look like. Because if you don't know how it should look like, you wouldn't know the operations to perform on it to get what you want. So how would this look like? Since this, you know, it's a 3 by 3 matrix because the rows are 3 and then the columns are also 3. So if it's a 3 by 3 matrix, that means its identity matrix will have 3 ones. The first one will be here, the second will be here, the last one will be here, and the rest will contain its zeros. So we'll have 0, 0, and then 0. So in your head, you have to perform operations so that this matrix would look like this. So in your head, you have to make sure that whatever you do at the end, you get this. You have to be mindful that you can get this, but the result you get here might not fit into the equation. Because when you are changing and this matrix becomes this one will definitely change to other figures. And the figures you get is what will represent the unknowns, the value for the unknowns. So sometimes you can get the result for this, but the results you get here might not fit into the equation, all 3 equations. It might fit even into 2, and the last one might not fit. Might fit into only 1, and the rest might not fit, which means the answer is wrong. So you have to be careful as you do it, so that your calculations will also be on point. Okay, so that's the next step. So after knowing how you change, what you are going to change it into, then we begin with the raw process. That's our various iterations. Okay, so let me erase this part. I wish I could erase fast. It's not being fast. Yay. So now I hope you've gotten this. So I'll move to a new sheet, and then on the new sheet, I'll just go straight to this point. I'll not rewrite the equation. I hope you understand. Okay, so let's write our matrix with the augmentations too. So we have 1, 3, 4, we have 3. Then we have 2, 7, 3. Then we have -7. Then we have 2, 8, 6. We have -4. So this is what you are coming to work on. So you bring the curly bracket. So please, as I'm solving, also solve so that you understand it. So the first thing I've realized when you do will help in order to make it easiest. We know in our heads the ones are diagonals, right? Okay. So first thing you have to do is change the figures below the 1 in order to get 0. So with our identity element, we know that we are supposed to get 1, 0, 0, 0, 1, 0, then 0, 0, 1. So the first thing you have to do is change everything below this 1 so that it becomes 0 first. Change this aspect to 0 first. So with this one, what can we do to change this 2 into 0? So what we can do is, you see, from the rules, we have 3 methods. Addition and subtraction is the first one. Multiplication and division by a scalar, and then interchanging. So here, if we use multiplication here, it might not work for us. If we use addition or subtraction, it might work because we have 2 here, then we have 2 here. So if you want to make this 0, it means if I subtract this rule from this rule, it means I'm going to get 0 for here, right? Don't think about the rest of the point, that's the 0, 0, 1. Just focus on making this one 0. Don't mind the figures you'll be getting here. Just focus on making this place 0. Whatever you have to do to make both this and this 0, do it. So the first iteration that we'll use is, so now you're coming to work on row 2. So row 2, what we can do is we subtract row 1 from row 2 so that the first element become a 0. So you write row 2 minus row 1. So when we do this, let's see what we get. So it means row 1, we're not going to touch it. So row 1 will be the same. We are come to touch on row 2, so row 2 will change. So we are saying subtract row 1 from row 2. So 2 minus 2 give us what? 0, right? Then 7 minus 8 will give us what? -1. Then 3 minus 6 will give us what? -3, right? Then -7 minus 4. So when you see minus in the equation, just use your calculator so that you don't make a mistake. Because if you make a mistake, you're going to come back and you get stranded on the way. So just use your calculator. -7 minus 4 give us -3. Then you write -3. Then you write the root 3 because we didn't work on root 3. So 2, 8, 6, right? Then -6, then -4, right? So let me rearrange this to look nice. So this will be our resulting matches. So the next iteration we will do will be on these new matches, not this, because now we've forgotten about this. So we're working on this, right? So our next iteration will be, let's say, so now we've made this one 0. And we are supposed to also make this one towards 0. So what can we do so that this 2 will also become 0? Let's say we have two. The first method is addition or subtraction, right? So if you subtract 0 from 2, you get 2. So it's not going to make us get 0, right? If you subtract 1 from 2, we'll still get a 1, which is not a 0. So ask yourself, what can I do? So now here you can, if you are using the method just like that, right? Even if, let's say, you are using division by scalar, when we divide this row by 2, this 2 will still be a 1, not a 0. So here you think of what? Okay, let me combine the operations. So maybe when you combine the operations, you might what? Get your answer. So before you even go to the method, just check, will the first method work? If not, will the second work? If not, will the third work? If not, then what can I do? Let me combine what? Operations. And I can assure you that when you combine the operations, you will get an answer. So what operation can we do? We know that 0 times any number is 0. So we can't use row 2 to work on row 3, right? So now let's come to row 1. Row 1 has a 1, and here is a 2. So what can we combine so that this 2 will become a 0? So if you multiply row 1 by 2, this one will become 2, right? Then when you are done, if you subtract, when you are done multiplying row 1 by 2, and the result, you subtract it from row 3, realize that row 2 will become 0, right? So it means this combination can what? Work. So sometimes you need to what? Think a little, not too much, just a little, to help you, to assist you. So our next iteration or our next step will be that. Then I come to work on what? Row 3, right? We are working on row 3. And what are we saying row 3 should be? We said let's put row 3 down because row 3 has its 2 already. Row 3. And now we want to do manipulations so that row 1 will have 2. So that when we subtract from row 3, we get what? Our 0. So we say 2 times what? Row 1, right? So now this is how our new matrix would look like. So row 1, you're not working on row 1. So row 1 will be there, will be the same thing. You're not working on row 2. So row 2 will also be what? The same thing, right? Which is 0. But our focus is on what? Our focus, I want to move this one. See. So row 3, our focus is on row 3, right? Okay, so what can we do so that row 3, this point becomes 0? And we said pick row 3, which is 2, minus. So here you use your calculator so that you get a precise answer. So 2 minus what? 2 times row 1. So 2 minus, that's this 2, sorry, we are not working with this. So this is not in the equation anymore. So this 2 minus 2 times row 1. So 2 times row 1 will give us 2. And the result will give us 0. So it means you've gotten 0. And you do the rest for the other one. So 2, so the next row 3 figure is 8 minus 2 times 3, which will give us what? 2. The next one is 6 minus 2 times row 1's figure is what? 4, right? Which will give us what? Negative 2. And the last one is negative 4. That's for the row 3 minus 2 times the row 1's figure, which is the 3, to give us what? Negative 10. So this is what we get for row 3. So now this is our new what our new matrix. So this one will be our new matrix. So now following this step, we've made our zeros, the zeros behind below this one, this pivot, this one, zero. So we are done with that. So the next thing you have to look at is change. Now focus on the last row so that it will become this. Let's focus on changing the rest of the elements of the last row into its form, which is 0, 0, 1. So now I've gotten 0. Our next focus is to get what? Another 0. The next one will be 1. Just don't focus on the rest. The focus should be on what? Changing this one into 0 and this one into 1. When we are done, I'll explain why I said start with the 0, 0, move on to the last one before the next. You get it? So how would we make these two also become a 0? So let's say we are using addition. If we add row 1 and then row 1 and row 2, you get 5, which is not 0, right? If we add or subtract row 3 from row 1, you get what? A 1, which is still not a 0. If you add row 2 and row 3, you get 1, which is still not 0. Let's say you divide row 3 by what? 2. You get 1, not a 0, because we can't multiply by 0. So you get 1, not a 0. So now what can we do? It means you have to use combination of what? Operations. So what can we do? We've seen that this is 2, right? And this is -1. So it means that if I'm able to change this 1 into a 2, and I add it to this 2, means I'm going to get a 0, right? If I'm able to change this -1 to -2, and I add it to this 2, I'm going to get a 0, right? So it means that our next step will be, so now this row is no more in the equation. This one too is no more in the equation. Now we are working on this to get a new what? Matrix. So our next step will be that we are still working on what? Row 3. And what we are looking for is to make these two become a 0. And using only the operations one by one will not get us that unless we combine them, right? So we've seen that if we work on the combination using row 2, we can get what? A figure that when we subtract, this 2 become a 0. So now row 3 will come. So always let the row you are working on come first, then the operations will follow. So row 3, since this is already a negative, you see, know that positive and negative overtake. So since this is already a negative, that means let's do add, because if we write negative, negative will give us a positive, which will not give us 0. Get it? So we'll do row 3 plus 2 row 2. You see that if you multiply row 2 by 2, the middle one will become a -2. And when you add it to this 2, this one becomes 0, and we get our 0 here, right? Okay. So now our resultant matrix would look like this. We are not working on row 1, so row 1 will be the same. Row 2, we are not working on row 2, row 2 will be the same. And we are working on row 3. We are saying row 3 plus what? 2 row 2. So we know that row 3, the first one is 0, right? And 2 times 0 is 0. So this one will still remain 0. And there's no change, right? Okay. So the next one, this is 2. That's row 3, 2 plus 2 times row 2. So 2 times this -1 will give us -2. So this 2 plus -2 will give us what? 0. And the next one, row -2. So when it's negative, use your calculator to be on the safer side, right? So row 3, the next one is -2 plus 2 times row 2, which is what? -3. And our result will be -8. Then we'll do it for the last one. Root 3 is negative 10 plus 2 times root 2, which is what? Negative 3. I will get what? Negative what? 16. Please hope you understand to this point. Okay, so now we've worked on the second zero for what? Root 3. And this will be our new matrix. Please take your time. I know you will understand. Okay, so this will be our new match. So this will no longer be in the scene. This will be what we focus on. So now our last focus is to make this one into a one, so that we'll get this, what is here, right? One. So what can we do? Let's say you are using addition. You are adding row 1 to row 2. When you add, means this 0 and this 0 will change, right? But we don't want them to change because we fed for it. So addition will not work. When you do subtraction too, this 0 will change, but 1 minus 0 will give us 1. Means this will go back to square 1. We don't want that. If we use multiplication, when you do times 2, get a 16. We don't want that. But when we know that when we use division by a scalar, we can get a 1 here, because any number divided by itself will give us 1. So to get 1 here, simply just divide by what? Negative 8. Then we get our 1, and we'll be done with root 3, right? So our next step will be that root 3, which is the row we are working on, will be root 3 itself divided by what? Negative 8, right? Then we write it down. So this one remain, row 1 remain the same because I'm not working on row 1. Row 2 to remain the same because I'm not working on row 2. Then row 3, that's what we're working on. We said divide row 3 by negative 8. 0 minus negative 8 is still 0. 0 minus negative 8 is still 0. Negative 8 minus negative divided by negative 8 will give us what? A 1. Then negative 16 divided by negative 8 will give us what? 2. Because the negatives will cancel, and 8 goes into 16 twice. So our results will be what? Our result will be this. This is what our new matrix will look like. So we'll forego this one. So you've seen that this is our first step, that is our second step, right? That is our third step, and this is our fourth step. You realize that now you'll be able to change this row into its form, which is 0, 0, 1. And you see that I've gotten a figure which is 2. So this should tell us that the third unknown figure is 2. So we are done with the third row. So now our focus should be on the second row, how to make the second row look like this. So our focus will shift to the second row. Forget about the first row for now, but focus on the second row. And make sure that when you're working on the second row, the third row will not change. It will still be 8001. Else you mess up big time. Okay. So now what can we do so that now when we look here, we know that it's 010. What can we do to make this 1? This negative 1 become a 1. If we say, let's say we are adding row 1 and row 2, this one will change and become 1. If you are going to start from square 1, it will not work. You are subtracting row 2 from row 1, still it will not work. If we say you are subtracting row 2 from row 3, we still get our negative 1. We have not gotten 1. So what we can do is we divide by what? Negative 1. Or you multiply by negative 1. Anyway, will give you a positive 1. Either you multiply by negative 1 or you divide by what? Negative 1. So let's say our next step. So now we are working on this matrix. So our next step is we are working on row 2. Row 2 is equal to row 2 divided by negative 1. So our result figure will be what? will be 1, 3, 4. That's row 1 will still be the same because we're not working on row 1 for now. Then row 2 become, since we are dividing by -1, 0 by -1 is the same as 0. -1 divided by -1 will give us 1. -3 divided by -1 will give us 3. -3 divided by -1 will give us 3. Then we'll bring our row 3 figures. You see, then we'll be done with this step. So you realize that now we've gotten our 1, which is here. So now it's left with the 0. What should we do so that this 3 becomes 0? You get it? What can we do to make this 3 0? Let's say you want to use addition. 1 plus root 3. You realize that this 0 will change to 1. Square 1 means it won't work. So don't go there. If you use subtraction, to this 2 will change to 1. Don't go there. And use, let's say, division. When you divide this row by 3, still we are going to get fraction. This one is going to change and you still not get a 0. So it means we are going to use combinations of what operation. And which of the rows that when you use the combination on, you can get this 3 to become 0 and you still maintain 0, 1. This row 3 because the first and the second are still 0. So if I work using row 3 means this 0 and 1 will remain the same. And this being a 1, I can make an effect on this 3, right? So we use what? Row 3 to make the change on row 2. What can we do? You see, when you multiply row 3 by 3, this one will become 3, right? And 3 minus 3 will give us 0. These ones will be maintained because of this 0. And we'll get back our equation or our figures. And it's simple as that, right? So our next step is the row 1, as we are working on row 2 now. So row 2 is that row 2, that's the row we are working on. So whenever you are doing combinations, let the row you are working on come first, so that the others will become, or the others before the others come. So row 2 minus, now we are saying when we multiply row 3 by 3, we're able to get a figure. So enable us get 0 in what? Row 2. So 3 row 3. So our result will be row 1 will be the same. Row 2, that's where we are effecting the change, right? So we are saying row 2, 0, which is 0, minus 3 row 2. And no 3 times 0 is 0, so the 0 will still remain. We are saying row 2, which is 1, minus 3 row 3. 3 times 0 is 0. So 1 minus 0 is still 1. If we maintain it, we are saying 3 minus 3 row 3. So 3 minus 3 will give us 0. So you see that we've gotten our 0 here. And the last one is 3 minus 3 root 3 as 3 minus 1, 6, which will give us what? Minus 3. Then we'll write our root 3 values, which will be the same thing. And we are done. Right? We are done. So now we've gotten rid of this row and we're working with this row. See that it's simple. So now it means we've gotten what? Row, the second identity. 0, 1, 0. And we've gotten our figure. Isn't it amazing? Now it means that finally, come to work on what? Row 1. So that we'll get what? 1, 0, what? 0. But we already have our 1 here, so hallelujah. So now we are come to work on 3 and 4 in order to change them to what? 0, 0. So now what can we do to make this 3, 0? Since this 0 and 0, this one's already 0, means whatever effect that will have on these two rows, they will never change this one. You get it? So that's the most important reason to start with making these ones, changing these ones before making on row 1. Okay, So we are coming to work on row 1. I want to change row 3. So let's use addition. If we add row 1 and then row 2, we still get our 1, yes. But the 3 will not get what? A 0. We are going to get a 4. And it means it's not going to work. But use subtraction, this will become 2. It's not going to work. But use division by 3, this is going to become 1/3. It means we are losing our 1, which is still not going to work. So we don't want to go there. So it means we have to use what? Combinations, right? Combinations. So we are coming to work on row 1. So we say that row 1 is equal, since you are using combinations, let the row 1 come first before any other operations will happen. So row 1, since we want to get a 0, means we're using a subtraction because there's no negative in the identity. So minus. We see that since this 3 is in the middle, right, means if we change row 2 to 3, then we can make this 3 0. If any number times 0 is still 0, so we can't use row 3 to effect a change on row 1. So row 2 must work. So you multiply row 2 by 3, then you subtract the result from row 1. Then you can get our 0. So you say that 3 row 2. Then our result will be, we are working on what? Row 1. So row 1, the first one is row 1 minus 3 row 2. 3 times 0 is 0. So 1 minus 0 is still 1, right? Then move to the next one. Row 1, which is this 3, minus 3 times 1, which is 3, will give us 0, right? Then the 4, row 1 minus 3 times row 2, which is 0, still give us our 4. Then row 3 minus 3 row 3, right? So use the calculator in order not to make a mistake. So 3 minus 3 row 3, where 3's figure is negative 3. So our answer will be 12, right? Then you put the rest of the rows figures there, the same thing. Then we get our negative 3. Then 0, 0, 1, 2. So this is our result. What we've gotten now after this step. So it means this will no longer be in the scene, right? So we have just one last thing to do, to change this 4 into 0, right? To change this 4 towards to 0, because we've gotten our 1, which is here, gotten our 0, means we need only just one 0. What can we do if we use addition? Let's say we are adding row 1 and row 3. Row 4 will become 5. If you are doing subtraction, row 4 will become 3, but it's still not a 0. And you know that we can't use row 2 because row 2 is 0. So any effect you do will not change the 4 here. So it means since the row 3 has a 1, which is what? A valuable number, which can help us work on the 4, then we use row 3 at this point, you see. So what can we do is combinations of what? Operations. It's what we can use here. So what we will do is, now we're working on row 1. It's equal to, since it's combinations, let row 1 come first. And since there's no negative in the identities, we use minus 4 root 3. Because when you multiply 4 by 1, you are going to get 4. When you subtract it from this 4, you are going to get 0, right? So our result will be, since we are working on row 1, 1, that's row 1, that's 1, minus 4 root 3. 4 times 0 is still 0. So our 1 will still remain. 0 times 4 times 0 is still 0. Then 4 minus 4 root 3, which is 1, give us 0, because 4 minus 4 is 0. Then our row 1 figure, which is 12, minus 4 times what? Row 3 figure, which is 2, give us what? 4. You see? Then get our 0, 1, 0. Let's replace the rest. 0, 1, that's 2. So now, this will be our final step. So from here, you can see that now this matches has been changed into its identity here, which is telling us that this result has also changed to this one. Hence, this one will be the what figures for our three unknowns. So since in our arrangement, the x1 came first, the x2 came second, the x3 came third, it means this 4 is for x1, this negative 3 is for x2, and this one 2 is for x3. So now, when you are done, that's not the end. You have to put them into the three equations to show or to ensure that your answers are what correct, because you can get the identity right but the answers may be wrong because of calculation errors. So I'll rewrite the equations here because not on the board. Then you punch it yourself with a calculator to see whether our answer is correct. So our first equation is x1 s1 plus 3x2 plus 4x3 is equal to 3. So punch in your calculator using these figures. The 4 is for S1. So let me write it here. That's X1 is equal to 4. X2 is equal to negative 3. And X3 is equal to 2. So put these figures in this equation and see whether you get the result, which is 3. So 4 plus 3 times negative 3 is negative 9, plus 4 times 2 give us 11. 4 times 2 give us 8, sorry. Then you see we got our 3, you did get that. Okay, so the next equation is 2x1 plus 7x2 plus 3x3 should give us negative 7. So put these answers here and see whether you get negative 7. So we have 2 times 4 plus 7 times negative 3 plus 3 times, you got negative 7, right? So it means yes, but don't rejoice. You have to check for the last one before you can conclude that indeed that's the answer. So the last equation is 2x1 plus 8x2 plus 6x3 should give us negative 4. So use the calculator to check. So 2 times 4 plus 8 times negative 3 plus 6 times 2. Got negative 4, right? Yes, so it means that our answer is correct. And we've what dissolved the equation using Gauss-Jordan method and we've arrived at our answer. So we started from here. We use this, so we use addition, subtraction, multiplication, and combinations. So when you are solving this, you have to ask yourself, will the first method work? What about the second, third? If not, then will combinations work? If yes, then you use that method. And always with the combination, the row you are working on should come first before the operations and then the other rows. And I can assure you that it will simple. So the reason why I started with changing this one, this 2 and 2 to 0 first is, so you see, if because this is a 1, and if you don't, maybe you don't change this to 0, right? Maybe you change this one to, like how we change this to 0 first. And maybe we want to work on this row, and we are using row 1. It means this 0 will change to 1 again. It means we are going to start all over. But because you see, when we change to 0, 0, if I want to make, when we change to 0, 0, let me use it. If I want to make any change on row 2, because this is already 0, making a change here will not affect the 0. right? And because I'm working on row 3 first before any other row, if I change all row three's figures to its identity 001, it's easy to work on row, because if I'm working on row 2 second figure, this first figure will not change, but this is already a 0. This is already a 0, so do not change. But if you don't change them and use row 1, means your zeros are going to change back to a 1. You're going to start all over and use long iterations. You get it? So first, change the zeros below this pivot, that's the 1 first, into zeros. Then work on row 3 first. Work on row 2 second, and before you work on row 1. If it's 4 unknowns, we work on row 4 first. As you change the down figures to zeros first, and you work on row 4, row 3, row 2, row 1. You see, so that will help you to what, limit your iteration. Also, it will make you confused. Please, you get it. So that's the end of this session. It has been a long one, but I hope it has been fruitful because I've taken my time. It took me a whole 1 week to be able to understand this fully on my own. And then I want to share it with you so that you also understand. Because helping a friend in need is all what the Lord wants. As long as God approves, as the name of the channel goes. So God bless you for watching. And I pray that as you practice, may the good Lord help you. May you understand it. If you have any question, please leave it in the comment section. And if you also want me to solve another example, just let me know, and I will gladly do it. God bless you. Enjoy your day. And also, please don't forget to share, subscribe to the channel. God will bless you. Bye bye.